Hello everyone. Today's lesson is lesson 94, Identifying Prime Numbers to 100. So, I want to know what numbers can I multiply to get a product of 2? Well, I can multiply 1 times 2. Can I multiply anything else to get the number 2? No, I can't. What about the numbers to multiply to get the product of 3? Well, I have 1 and 3. Are there any other numbers? No, there aren't. Okay. Well, what about 4? Well, 4 equals 1 times 2. Are there any other factors I can use to make 4? Yes, I can make the numbers 2 times 2. Okay. So, the number 4 has more than 2 factors. Its factors are 1, 2, and 4. 2 and 3 only have 2 factors, 1 and itself. The number 2 and 3, we call these prime numbers. Prime numbers only have 2 factors, 1 and itself. All the other numbers are called composite numbers. Composite numbers have more than 2 factors. Okay. So a prime number is a number greater than 1 with exactly 2 factors, 1 and itself. A composite number are numbers greater than 1 that are not prime. Okay. So if I want to mark the prime numbers with red. So far we have 2 and 3. Okay. So let's try 4. We did 4 and 4 is not prime. So let's try 5. Well, 5 equals 1 times 5. Are there any other factors? Nope. So that means that 5 is a prime number. Well, what about 6? Well, 6, I have 1 times 6, but I also have 2 times 3. So that means that 6 is not a prime number. What about 7? 7, the factors of 7 are 1 and 7. And there aren't any other factors, which means that 7 is a prime number. Now, I'll show you an easy way to find all the prime numbers up to 100. More than 2,000 years ago, a Greek mathematician, Eratosthenes, I believe is how you say it, discovered a way to find prime numbers. His method for finding prime numbers was named after him. It's called the Sieve of Arrest. A sieve is like a strainer. When we cook, we may use a sieve to drain macaroni. So now we're going to use Eratosthenes' method to help us find prime numbers. Okay? So I'm going to be finding all of the prime numbers on this chart. And our first set of 5 numbers were 2, 3, 5, and 7. Now the number 1 is not a prime or composite number because it has only one factor itself. So we just call number 1 a unit. Okay. So I'm going to cross off all the numbers that are multiples of 2 to start off with. Okay. So, because if anything is a multiple of 2, that means it has a factor of 2, so it's not prime. So I have 2, 3, 4, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I'm seeing a pattern here. You might notice that the numbers that are crossed off are all composite numbers, okay? And all the numbers are in a column under the 2, 4, 6, 8, and 10. So all of these numbers are composite numbers because I can divide them by 2. I'm going to go ahead and get those all crossed off. Alright, so now I'm going to find the multiples of 3, okay, because that's the next prime number. So we're going to do that by crossing off the multiples of 3. So we have 3, and then we have 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. Have you seen a pattern? If you notice, the multiples of 3 follow each other in a diagonal line. Okay, so if I continue these diagonal lines, I'd find that 51 is a multiple, and all these numbers are multiples of 3. Okay? And then all these multiples. There we go. Okay, so then I just have to find this corner. So 57, the next one would be 60. Okay, so then I can follow this line down. Okay, and all those are factors. 80 is not, so we have 87 and then 90 and then 99. So all of these numbers are factors of 3. Or, I mean, multiples of 3. Okay? I believe that's all of them. Okay, so now we're going to find the numbers that are factors of 5, or multiples of 5. Okay? So starting with 5, we have 5, 10, 15, 20, 25, 30, 35, 40. If you notice the pattern here, all the multiples of 5 are in columns from 5 and 10. So I can follow these lines down, and all of these numbers are composite numbers because they're multiples of 5. So our last prime number on this top row is 7. So we need to cross off all the multiples of 7. Okay, so I'm going to do that with a horizontal line. So we have 7, then 14, then 21, 28, 35, 42, 49, then 56, 63, 70, 77, then 84, 91, 98. Okay, so everything that I haven't crossed off should be a prime number. So let's take a look. We have 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 47, 53, 43, missed that one, 53, 49, 59, 61, 67, 71, 73, 79, 83, 89, and 97 are all of my prime numbers. Okay, we'll be using prime numbers to help us simplify fractions, so that's why it's good to know at least some of these. And that's it for this lesson. Thanks for watching.